Okay, question 3. The first part of the question, we'll call it part A, is proving that when A doesn't equal 3, then there'll be a unique solution. So again, we have 3 different equations, which is too hard for matrices in Year 12 methods. So we need to change it into 2 equations. That's what you can always do. When you have 3 equations like this with so many unknowns, we just need to simplify it into 2 different equations by elimination or substitution. So let's do elimination. You can do whatever you like, but I find elimination easier. So we are going to get rid of the x variable because it's, well, you can get rid of whatever you like, but it's an easy one to get rid of. So equation 1, let's multiply that by 2 so that we get 2x here, because then we'll be able to take away equation 2 from that to get 2x, take away 2x, and then there's 0x left. Okay, so equation 1 multiplied by 2, 2x plus 6y plus 8z equals negative 10. Okay, now I've named this equation 4 because that's what you had done on your worksheet, so I'm just keeping it somewhat consistent for the start. But you don't have to label it, or you can label it A or whatever you like. It's just a nice way to keep track of it. Okay, now we're eliminating the x variable because 2x is in this equation here, equation 4, as well as in equation 2. So like I said, now we can go equation 4, take away equation 2, and then we'll have 0x. So, just reading it out from here, 2x plus 6y plus 8z. Now take away the left-hand side of equation 2. Take away 2x, take away 5z plus z, as here. And now the right-hand side, negative 10, take away 5a, Okay, now we simplify this. So all we do, we get rid of these. The negative 2x plus 2x is 0x, so we don't need that anymore. And what else can we simplify? Okay, 6y take away y is just 1y. So just 1y left. And then 8z plus z equals 9z. So that's the left-hand side simplified, y plus 9z. And then the other side, you can't simplify that, so we'll leave that as negative 10, take away 5a. And I've just put an asterisk, a star next to it, because we need to come back to this equation. It's a good equation, because it doesn't have the x variable in it anymore. Okay, now, we've used, just like in the other question, now we've used equation, which one did we use? Equation 2 and equation 1. So when you try to eliminate something, you need to make sure you've used at least each equation once. So now we need to make sure we use equation 3 and get rid of its x, it's 3x, and you can use whatever you like with that. So you can use equation 1 or equation 2, but it will be easier to use equation 1 because to get 3x here, all we do is multiply this by 3. If we wanted to use equation 2, we'd have to multiply 2 by 3, and then so the whole equation by 3 to get 6x, and then multiply the whole of equation 3 to get 6x as well. So it's much simpler just to use, if you see the coefficients 1, that's always a good sign. So now we're going for equation 1 and equation 3. So now you can see we will have used each equation at least once. So, yes, so we can use equation 3 with either equation 1 or 2, but 1 will be easier due to the coefficient of x just being 1. Okay, so let's multiply all of equation 1 by 3. Remember, what you do to the left-hand side, you do to the right-hand side. So, 3x, just follow down here, 3x plus 9y plus 12z equals negative 15, as written here. And now that we have the 3x here, we can subtract the whole of equation 3 from equation 1. Or you could do it the other way because they're both 3x. But we're going to do the new equation 1, which you can call equation 5 if you like. As I said, you can call them whatever you like, it doesn't matter, as long as you can keep track of them. So we're taking away equation 3 from this new equation, which is a modified version of equation 1. Okay, so follow here, 3x plus 9y plus 12z from here. And now take away 3, take away 3x, take away 8y, take away az, as you can see here. And then the right-hand side equals negative 15, and then take away the right-hand side of equation 3, take away b. take away b. Now all we do, we simplify this. So you can see we've got 9y here, 8y here. So that 9y take away 8y is just y. Okay, that's where that comes from. And then 3x take away 3x. That was the whole point of choosing these two equations and modifying this by multiplying it by 3, because we wanted to get rid of the x variable. So now we have 3x take away 3x is 0x, so now we don't need to write the x in the equation, which is our goal. And the last part, we have 12z take away 8z, so just write that out. And this side you can't simplify. I've brought these into the brackets for the matrices that we will be using later on, so just collect those two coefficients. So 12 take away 8 all times by z. Okay, again, just put a little star next to it because these are the two equations. We used to have three equations with the three main variables, y, x, and z, and we've used elimination to get rid of x to now have just two equations without x. So now we have just y and z are the main variables, and then also a, which the a and b, which the question depends upon. Okay, good job for following along. Now, in the next part, we need to write them in the matrices like the last question. So, I've just written it out. Remember, this is where I'm getting it from, these two equations. Y plus 12 take away az equals 15 take away b, and y plus 9z equals negative 10 take away 5a. I've put them in the equations like this. So, we know that this is just another way to rewrite it. So, y plus 12 take away az, which is, these are the left-hand sides of those two starred equations that I just read out. And I just wrote them in a matrix form. So, to turn it back into this, you just go this times this, 1 times y, and then plus 12 take away a all times z, which is here. And then the bottom you go here times here, which is y, plus 9 times z. Okay? So it's just a different way to it's like rewriting this turns into this. And then this was the left-hand side of those two starred equations. So if this equals this, then this is still equal to the left-hand side of the two starred equations. So this, I just rewrote it again. So this is still the same thing. The left-hand side of the two starred equations is equal to this. And so this is actually the right-hand side. So let's quickly go back here. Negative 15 take away b and negative 10 take away a. So I've just said that left-hand side equals the right-hand side. Or again, you can write it in this matrix notation. Ax equals b. This is a here. This is x here. And this is b here. But that's not so important. Now, we're doing the determinant again. The determinant of a here equals AD take away BC. Now remember, any matrix, 2 by 2 matrix. Oh, I wrote that wrong. Start again. A, B, C, D. So the determinant equals A times D take away B times C. So here, 1 times 9. Oh, what is that? 1 times 9 take away 12 times A times 1. So 9 times 1 take away 12 times A times 1, which equals 9 take away 12 plus A, because negative times negative is a positive, which equals A take away 3. So I'm just simplified that determinant. So let's just quickly check what the question asked us to do. Okay, we need to show that if A doesn't equal 3, then there's one solution. So we'll show there's always one solution when the determinant doesn't equal 0, because remember, if the determinant equals 0, there is either no solution or infinite solutions. So if it doesn't equal 0, this is always. If it doesn't equal 0, one solution. That's the only other option for these questions. Okay, so this is the determinant from that matrix. If it doesn't equal 0, there's one unique solution. That's just a fact. So now we need to show if A take away 3 doesn't equal 0, then there's one unique solution. So therefore, for one unique solution, A can't equal 3. So there, we proved it like they wanted. When A does not equal to 3, there is one unique solution. Okay, that's part A of the question done. Now, last page, almost there. Part B. Now, the question says, the second half says, given that A equals 3, find the value of B for which the equations have an infinite set of solutions. Okay. So now we know A already equals 3. So, just like before in the other question when we subbed the values of K, because once we got there, then we knew it was going to be those values. Now we know A equals 3, so we sub it back into those two equations from the start, which we got when we eliminated X. So we're going back to after we got these 3 equations down to 2 equations, but not after that. Okay, so these 2 start equations that came about from eliminating X, we sub in A into those. So here was one equation, y plus 9z equals negative 10 to go 5a. So just do 3 times negative 5, negative 15, and then simplify, y plus 9z equals negative 25. Okay, so that's our first one here. Then the second start equation was y plus, in brackets, 12 take away a, close brackets, z equals negative 15 take away b. So now this arrow just means I've subbed in a equals 3 because it said given that a equals 3. So y plus 12 take away 3 z equals negative 15 take away b. Simplify this, 12 take away 3 is 9. So y plus 9z equals negative 15 take away b. Now we don't know what b is yet. Okay, so these are 2 simultaneous equations. Okay, these are 2 lines. If there is no solution, they must be parallel. Because when they're parallel, remember, when there's no solution, when they're parallel, they will never ever meet. So here it's not meeting, here it's not meeting, here it's not meeting. Over here, it's still going to be parallel. They'll never join up. And these are the 2 options. If there are infinite solutions, they must be the same line, okay? So for infinite solutions to occur, then they must be the same thing, because here and here and here and here and here, they've met up the whole way because they're the same line. So like we did before, we made x the subject. Well, here we're making y the subject. Okay, this is our first equation. We're making y the subject. So move 9z to the other side. Y equals negative 9z. Take away 25. That's the first one. And here's the second one. Y plus 9z equals negative 15 take away b. So move this to the other side. So we get y equals negative 9z. Take away 15 take away b. So again, like I've written, you can see they're the same gradient. So we just need to see, are these c values the same? This changes whether they're going to be parallel or the same line. Ooh, that's the same line. And that should be a straight line as well. Just bad drawing. So for them to be the same, this c value must be the same. So negative 25 must equal negative 15 take away b. So negative 10 equals b, so b equals 10. That's if they're the same line. And obviously if they're not the same, then they must be different lines, so parallel, because the determinant, we already worked out a equals 3. So the determinant does equal 0. So if they're different, then negative 25, we're just going from here, negative 25 can't equal negative 15 take away b. So negative 10 can't equal negative b, so b can't equal 10. So the question asked us, if a equals 3, find the value of b for which the equations have an infinite set of solutions. For an infinite set of solutions, they must be the same line, so therefore b equals 10.